In part B on the second page, for problem number 1, we need to factor, then state the zeros of the polynomial x to the fifth plus 3x to the third minus 10x. Now, since every term has an x in it, the first thing I'm going to do is factor out the x. Then, I'll be left with x to the fourth plus 3x squared minus 10. And now, since the degree of this term is 4 and this one is 2, by that I mean the middle term has a degree that is half of that of the leading term. That's going to mean that we can factor this just like a quadratic. So I'll keep that x out in front and break this one up like a quadratic, factoring x to the fourth into x squared and x squared. Now I look at the factors of 10 to try and make a 3, and those two factors are going to be 5 and 2. 5 times 10 is 2, and plus 5 minus 2 makes 3. Once this thing's completely factored, it's not bad trying to find the zeros. In order to do that, we take each factor and set it equal to 0. Once they're all set equal to 0, we solve them. This one's already done, x equals 0. For the second one, we need to subtract 5 and then take the square root. Since we put the square root in, we're going to need plus or minus out in front, and the square root of a negative is I. The square root of 5 is going to be the square root of 5, and the square root of negative 5 would be square root of 5i. Do it again now with x squared minus 2 equals 0. Add 2 to both sides, and then square root both sides, so x is equal to plus or minus the square root of 2. And those are all of our zeros. In part B, the polynomial is x cubed minus 4x squared plus 7x minus 28. And since this has 4 terms in it, we can't exactly factor it the same way we would a quadratic. So the method here is what we're going to call factoring by parts or factoring by grouping. Either way, what we're going to do is cut the polynomial in half and look at each half. So look at each part or look at each group. And just looking at the first group, x cubed minus 4x squared, we're going to factor out the common factor. In this case, that'll be x squared. When we do that and we take an x squared out of x cubed, we're just left with x. Then, in the second term, when we take the x squared out, it'll just be 4. Looking at the second group, the positive 7x minus 28, the common factor there is a 7. So I'm going to divide out a positive 7. What I'm left with, after dividing out 7 here, is x, and dividing that by 7, we're left with minus 4. Once again, taking a look at these two groups, those two terms each have an x minus 4 in it. So I'm going to factor the common factor out again. This time that common factor is x minus 4. And when I take x minus 4 out of the first group, the only thing that I'm left with is going to be x squared. In the second group, when I take the x minus 4 out, I'm left with plus 7. Now these are my two factors. In order to find the zeros, I'm going to take each factor and set it equal to 0. Then solve. Adding 4 to both sides in the first equation, we get x equals 4. In the second equation, we'll subtract 7 and then take the square root. Since we put the square root in, we're going to need a plus or minus, and the square root of negative 7 is going to be square root of 7i. And those are all of our zeros. For the third one, we're going to factor the sum of 2 cubes. In order to do that, this is going to break up into a small factor and a large factor. The small factor is going to have 2 terms in it, the cubed root of each of the terms above. The cubed root of 27 is 3, and the cubed root of x cubed is x. Then the second term is going to be the cubed root of 125, which is 5. Now, in order to determine the 3 terms in the longer factor, I tell everybody to remember square, together, square. That means we're going to go back to our binomial and square the first term, then take the opposite of multiplying these two terms together, and then square the last term. Square, together, square. So, if we're going to do square, together, square 3x. Squaring 3 is 9, squaring x is x squared. Square, together, square. When we multiply these two together, we'll get 15x, but it has to be the opposite. Since our binomial has plus in the middle, that means our longer factor is going to have minus in the middle. Lastly, square, together, square. I'm going to square the last term. That means we'll end up with plus 25. So that's how you factor the sum or difference of two cubes. First, take the cube root of each term, then square, together, square. Finally, to find the zeros, we're going to have to set each of these factors equal to 0, and then solve. That's not too difficult with the first one, because we'll subtract 5 and then divide by 3. So x equals negative 5/3. A nice easy one. But the second one will never be that nice. Every single time you'll have to use a quadratic formula in order to solve it. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, a nice thing is going to happen most of the time, and that's underneath this square root. See, since we'll have negative 15 squared, that's the same as 1 of these 15 squareds. Because when you square negative, it'll turn positive anyway. Next, I'm going to subtract 4 of these products of 9 times 25. And the thing is, 9 is 3 squared and 25 is 5 squared. So really, 9 times 25 is another 15 squared. And it'll happen every time that what is under the square root is going to be 1 minus 4, that's negative 3 of those 15 squareds. And what I'm saying is that every time we'll have these two numbers be the same. Now when we simplify, we'll have 15 plus or minus. The square root of that 15 squared is 15. The square root of 3 is square root of 3, and the square root of a negative is I. Then we divide by 18. So divide each term. Since we can simplify 15 over 18 by dividing numerator and denominator by 3, that's what I'm going to do. And I'll get 5 plus or minus 5 square root of 3i all over 18 divided by 3, which is 6.